Hello, students. Welcome back to NEET Masterclass with Sparkle. Today, I have come up with the topics electric field and charges and electric potential and capacitance. As you know, that this comes under the umbrella of electrostatics, and it forms a very important part of the NEET paper. Around 12 to 16 marks of questions are asked from this portion, and the questions are very basic. They are purely NCRT based, purely formula based, and very scoring. So need not fear this chapter. You just have to learn the formulas and practice some basic and standard questions, and you will definitely see a similar kind of question in your NEET exam. So today's questions, as I tell you every time, that they are in line with the thought process of NT and NEET. We have done a deep dive research on the different questions year by year, and we have come up with a few type of questions, standard type of questions that we'll be solving in the class. And it is expected from you guys to learn them, practice them, learn the formulas, and you will definitely see similar questions in your final exam. So let's start with the questions. So the first question: an alpha particle is accelerated through rest through a potential v volts. The kinetic energy. So a relation between kinetic energy and the accelerating potential or potential difference. So we know that work done is equal to change in kinetic energy is equal to potential difference into q, or this will be the accelerating potential in this case. And the answer is in electron volts. So options are in electron volts, so we have to find the answer in electron volts. It can also be found in joules, but generally this electron volt options are given. So we have an alpha particle, and the charge on alpha particle is 2e, 2 times of charge on electron. So the kinetic energy gained will be 2e into v, so it will be 2 electron volt. So it's a very easy question. You just have to remember this formula and put it in terms of put the charge in terms of the electronic charge n into e, and n into the accelerating potential will be the magnitude of kinetic energy in electron volts. All right. Next question. A particle of charge q and mass m is projected with speed v naught perpendicular to the uniform electric field E naught at t equal to 0. The time after which its velocity makes an angle 45-degree with the electric field. So let's draw the diagram first. So we have like an electric field, and our charge is projected perpendicular to the field with speed v naught. All right. Now when it is projected perpendicular, it will do some parabolic motion, and we are asked to find uh, the time after which its velocity will make angle 45-degree with the electric field. So velocity will make angle 45 with the electric field when both horizontal velocity and the vertical velocity, they become equal or become equal to v naught. Then only it will be making angle 45-degree with the direction of electric field. All right. So our electric field is E naught. Now the force acting here will be E naught into Q. The acceleration will be E naught Q upon M. Now let's divide the entire um, parameters in x and y direction. This is my y direction and this is my x direction. So in y direction, the initial velocity is v naught, and it will remain v naught because the electric field or the force is acting in the horizontal direction. Uh, there is no acceleration in y direction. So ay will be 0. Initial velocity is v naught. Initial velocity in x direction is 0 over here. Acceleration in x direction is e naught q upon m. So we have to find the time when the horizontal velocity also becomes v naught. That's the question basically now. So we just apply the equation of motion v is equal to u plus at. Initial velocity is 0. Final velocity is v naught, acceleration is e naught into q upon m into t. So the time comes out to be v naught m upon eq. This is the time when horizontal velocity will become v naught. It will become equal to the vertical velocity, and it will make angle 45 degree with the electric field. So this will be my answer, v naught m upon eq naught. All right. Next question. Total flux through the Gaussian surface. Again, a very basic problem, but like you have to, remember it. So we know that when there is a closed surface, the flux due to outside charge is zero. The net flux due to outside charge is zero. Flux is only considered due to inside charges. So Q inside over here is 2 microcoulomb. So flux will be 2 into 10 ki power minus 6 upon epsilon naught. All right. And we know that 4 pi epsilon naught is equal to, or 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9. So from here we can write epsilon naught as, or 1 upon epsilon naught as 4 pi into 9 into 10 to the power 9. So I'll put those values. So 2 into 10 ki power minus 6 into 4 pi into 9 into 10 to the power 9. So it will become how much? It will become uh, 72 pi into 10 to the power 3. So this will be my flux. So you have to, keep this in mind. Putting it 8.85 won't get you to the options. So sometimes in easy question, they will trap you with such kind of stuff. So you have to see the options and judge कि अच्छा पाई वाला term आ रहा है तो epsilon naught में पाई वाला term कैसे लाना है. So you have this thing. All right. Next question. A uniform electric field having strength E exists in the region as shown in the figure. Consider 3 points A, B, and C having potential VA, VB, and VC respectively. Choose the correct option. So see, we are set to compare the potentials. So perpendicular to the electric field, the potential is constant. So line BC is perpendicular to the electric field. So VB will be equal to VC over here. All right, and we know that potential decreases in the direction of electric field. Okay, yeah, dV is equal to minus of E dot dr. Potential decreases in the direction of electric field. So VA will be less than VB and VC. So this will be my option. So VB and VC will be equal and they will be greater than VA. This will be my answer. All right. Yes. This question again. See, in capacitance, the slab equivalent uh, dielectric constant, or maybe K equivalent, is a very important concept. You have to remember this. Many times question has been asked from this portion. So two conducting plates of area A and separation D filled with dielectric medium as shown in the figure. Given that the dimension of both the dielectrics are same, the equivalent of the system. So ये कैसे filled हैं? They are area distribute हो रहा है A by 2 and A by 2, and entire space D is filled. So they are connected in parallel. So K equivalent formula is K1 A1 plus K2 A2 upon A1 plus A2. This is the general formula. When areas are equal, it simply becomes K1 plus K2 upon 2. So it will be K plus 2K upon 2. So it will be 3K by 2, K equivalent. And C will become K equivalent into A epsilon naught by D, or 3K by 2 into A epsilon naught upon D. So this will be my answer. So again, it is easy, but you have to know this basics. Yes, similar question on graph. A charged capacitor with dielectric medium shown in the figure, the correct variation of electric field versus distance would be. So see, we know that wherever there is vacuum or there is no slab, the electric field is, let's say, E. Here also it is E. Wherever the slab is there, the electric field will be E by K, and K has value greater than 1. So the electric field will be like will have graph like this. Let's say here the graph is like this, here the graph is like this, and here between d by 3 to 2d by 3, the graph will be like this. All right. So electric field here will be E and here will be E upon K. So this type of graph will be the option. Electric potential at A due to the dipole given. So potential due to dipole, the general formula for dipole is K into P vector dot R vector upon R cube. All right. So when we solve it, we get Kp cos theta upon r square. So this is my formula for dipole. You have to remember the vector form as well, and you have to remember the magnitude as well. So here the theta is 30 degree. Theta is always taken with the dipole. So it will be Kp by r square into root 3 upon 2. So root 3 Kp upon 2r square. So this is my option. Now, concentric shells, again, a very important concept. Initially, both the concentric hollow conducting shells of radii A and B have the same charge shown in the figure, and the switch is open. So it is not earth. Find the flow of charge through the switch when it is closed. So we here whenever we earth a shell, what happens is the some amount of charge will either flow into the earth or some amount of charge will flow from the earth, and charge of the shell will uh, change from its initial value. And also the potential of the sphere, it becomes zero if inner sphere is or inner shell is like earth. इनर शेल का जो पोटेंशियल है वो जीरो हो जाएगा इफ आउटर शेल इज अर्थ. आउटर शेल का पोटेंशियल जीरो हो जाएगा. So let's say the new charge that it gets is q, all right, and its potential becomes zero. So let's write the expression for potential of inner shell. So v inner shell, it will be due to inner shell itself, it will be kq upon a, and due to outer shell, it will be k capital Q upon b. And see, this is 0. So I'll write it as kq by a will be equal to minus of kq upon b. K and k gets cancelled. Q will be equal to minus of a q upon b. So this is the final charge. Now, we have to find the flow of charge through the switch when it is closed. So initial charge was capital Q. Now the final charge is Q. So charge flown will be how much? Final charge minus initial charge. So it will become minus of A by B into Q minus of Q. So it will become minus of Q into A plus B upon B. So this will be our answer. All right. So the concept over here is whichever shell is earth, its potential will become zero and its charge will change. अगर कोई दूसरा शेल है जिसको हमने नहीं डिस्टर्ब किया है, जिसको अर्थ नहीं किया, तो उसका चार्ज एज इट इज रहेगा. ऑलराइट. नेक्स्ट क्वेश्चन. A bubble is charged to a potential 6 volt if its radius is tripled, and then the potential of the bubble becomes. All right. So basically, we know that if we have a bubble over here and this is its radius, so capacitance will be 4 pi epsilon naught into r. All right. It's We can write its charge as q is equal to c into v. ठीक है. अच्छा, अब हमसे बोला है इट इज चार्ज टू अ पोटेंशियल 6 वोल्ट. सो द चार्ज ओवर इट is 6 into 4 pi epsilon naught r. Now, when we make any change, this charge will remain the same. All right. Now, the radius is tripled. So, let's triple the radius again. Apply the same formula. Q will be equal to C dash into V dash. So, charge will remain the same. 6 into 4 pi epsilon naught r will be the charge. New capacitance will be 4 pi epsilon naught into 3r into the new potential V dash. All right. So 4 pi epsilon naught and 4 pi epsilon naught gets cancelled. R and R gets cancelled. Now V dash will become 6 upon 3 and it will become 2 volt. All right. So this is a simple question. When two identical spheres having charge 4 coulomb and 16 coulomb are kept at certain distance apart, then the force is F. If they are touched again and kept at the same distance, the force becomes. So such kind of questions have been asked in the past, and it is very likely that such questions can be asked in the future as well. So it makes it important. So let's say we have like two spheres, small spheres. They are separated by some distance r, and they have charges like 4 coulomb, microcoulomb and 16 microcoulomb. So force between them will be k into 4 into 16 into 10 की power minus 12 upon r square. This is my. Now what we do, we touch these charges. So touch करने से क्या होगा? The charges on them will become equal, identical है. So total charge is like 20. So each will have 10 microcoulomb and 10 microcoulomb charge. I hope you know this कि when equal spheres or are touched, then what will happen? The charge on each will become the half of the total charge. बराबर बराबर बढ़ जाएंगे. And they are kept at same distance r. So the f dash over here will become k into 10 into 10 into 10 to the power minus 12 upon r square. So divide these two. So f upon f dash will become, these all will get cancelled. So only we are concerned about this 4 into 16 and upon 100. So this will become 25. So f dash will be 25f upon 16. So we have to just do a little calculation. The concept is the Coulomb's law only. Okay, you have to just apply the Coulomb's law. Next question. These graphs are very important. Whatever graphs are in there in this particular chapter, both of the chapters, you have to learn all the graphs. There are high chances that question can be directly asked, and it's a very easy question. Like even if when you turn the pages of your paper and you see such type of options, you know that you know it, you have studied it, the teacher has told you to study it or learn it many times. So yeah, a non-conducting, a uniformly charged non-conducting sphere of radius r has total charge q. If r is the distance from the center, the correct graph between electric field and r is. So electric field का graph, तो inside हमें पता है, the electric field is directly proportional to the distance inside, and outside it is inversely proportional to r square. So this टू ग्राफ्स तो नहीं होंगे, ये वाला ग्राफ इज माय आंसर. ऑलराइट. अच्छा, ये ग्राफ किसका होता है? दिस इज द ग्राफ फॉर पोटेंशियल. अगर पोटेंशियल का पूछा होता तो वी वर्सेस आर ग्राफ ये करेक्ट होता है नॉन कंडक्टिंग स्फीयर के लिए. तो दिस यू हैव टू रिमेंबर एंड डोंट गेट कंफ्यूज्ड अमंग इलेक्ट्रिक फील्ड एंड पोटेंशियल. ऑलराइट. Equipotential surface for a point charge at a infinite distance is. So for a point charge, the equipotential surface will be basically spherical. Okay. A parallel plate capacitor of capacitance C has charge Q. If the potential difference between the plates is V and separation is D, the energy density between the plates is. So energy density. What is energy density? Energy density is energy stored per unit volume upon volume. And the direct expression for is half epsilon naught into E square. All right. This is the expression for energy density. Now we know that um, E will be equal to V into D. All right. Sorry. V will be equal to E into D, or E will be equal to V by D. We know this. All right. So, and V is the volume, it is given. Potential difference between the plates. Yeah. So, this thing will become half of epsilon naught into V upon D whole square. All right. So, this will be my answer. If a soap bubble is given a negative charge, then its radius. You give it a negative charge or a positive charge, any charge you give it, it will expand. Why it will expand? Due to mutual repulsion. So the radius will increase. If two capacitors C1 and C2 have equal amount of energy stored in them, the charges on the two capacitors will be in the ratio. Such questions are very common. It is a very important question. So energy stored in them is same. All right. Then the charges. So charge and energy का relation पूछा है तो which formula will use? Will use Q square upon 2C. All right. So Q1 square upon 2C1 will be equal to Q2 square upon 2C2 because the energy stored is equal. So Q1 by Q2 will become C1 by C2 to the power 1 by 2. So this will be my answer. Simple question, but you have to remember the formula. अब इसमें आप energy stored equal to half CV square लगाएंगे तो nothing will happen. ओके सो यू हैव टू थिंक कि चार्ज का रेशियो पूछा है तो चार्ज के टर्म्स में फॉर्मूला हमें यूज करना है इन द फिगर शोन बिलो चार्ज ऑन द इनर स्फीयर इज 4q and on the outer shell is q when the switch is closed. So we know that when switch is closed, all the charge of the inner shell, all the charge of the inner shell will flow on the outer shell. All right. So all the charge जो होगा वो आउटर शेल पे चला जाएगा। आपसे कैलकुलेट करने को बोलेंगे कि आउटर फाइनल चार्जेस क्या हो जाएँगे? तो फाइनल चार्जेस ऑन आउटर शेल विल बी योर 5q एंड इनर शेल का चार्ज 0 हो जाएगा। ऑलराइट, नेक्स्ट क्वेश्चन। A particle having a charge minus q and a mass m moves in a circular orbit of radius r about a fixed charge plus q. The relation between the radius of the orbit and the time period is given by. It's a very important question. So we have a fixed charge plus q and a negative charge minus q is revolving around it in some circle of radius r. Okay. Now, whenever you are given that something is moving around in a circle, you have to think in terms of the centripetal force. So we know that the electrostatic force here will provide the centripetal force. So we can write K capital Q small q upon r square will be equal to mv square upon r. So from here over here we can write V square will be equal to K capital Q small q upon mr. All right. And the time period, as we know, that time period is 2 pi r upon v. So let's square it. So it will become t square is equal to 4 pi r square upon v square. Let's put the value of v square over here. So t square will become 4 pi r square upon k capital Q small q upon mr. So it will become k capital Q small q upon mr. So it will become 4 pi r cube m upon k capital Q small q. All right. And k को भी आप 1 by 4 pi epsilon naught लिख सकते हैं. So this entire thing will become 16 pi square epsilon naught r cube m upon capital Q small q. So find the option कि यहाँ पर क्या हो जाएगा. r का वैल्यू पूछा है उनने तो capital Q small q t square upon 16 pi square epsilon naught m. So this looks like the answer. T square वाली टर्म आएगी and r cube वाली टर्म आएगी. So you can easily get the answer. Okay. So ये जब भी कोई गोल घूमने वाली चीज आएगी अराउंड अ लाइन चार्ज और मे बी अराउंड अ चार्ज, you have to think the same way in terms of centripetal force and time period will be 2 pi r upon v for circular motion and solve it. An electron falls. Now, electric potential due to a dipole moment at equatorial positions at distance r from its center is. Equatorial position पर potential zero होता है. You have to remember, don't get confused in electric field and potential. ये क्वेश्चन मैं कराया ही इसलिए हूँ क्योंकि बहुत बच्चे पोटेंशियल और इलेक्ट्रिक फील्ड में कंफ्यूज हो जाते हैं डाइपोल के लिए. You have to remember the correct formulas, the correct conditions, and then solve the problems. पैनिक में आकर गलती नहीं करनी है. An electron falls through a distance 1.5 centimeter in a uniform electric field of magnitude 2 into 10 ki power 4. The time of fall is. So in such cases, what you need to do, we have to find the acceleration. So acceleration will be eq upon m. So it will become 2 into 10 to the power 4 into 1.6 into 10 to the power minus 19, 9.1 into 10 to the power minus 31. So this will be my acceleration. So it falls a distance 1.5. So formula that you'll have to apply is s is equal to half of 80 square. So 1.5 upon 100 is equal to half of the entire acceleration, 2 into 10 to the power 4 into 1.6 into 10 to the power minus 19, 9.1 into 10 to the power minus 31 into t square. Now इसको थोड़ा सा स्मार्टली सॉल्व करो, लाइक 2 एंड 2 गेट्स कैंसल्ड, ये 1.5 और 1.6 को कैंसिल कर दो। वो आपसे देंगे इस तरह के क्वेश्चन, जब इजी क्वेश्चन रहेगा तो वो कैलकुलेटिव बनाने की कोशिश उसको करेंगे। ऑलराइट, सो नाउ सी टी स्क्वायर क्या टर्म आ रही है, 9.1 इंटू 10 टू द पावर माइनस 31 आएगा अपॉन 10 टू द पावर 4 इंटू 10 टू द पावर 2 इंटू 10 टू द पावर माइनस 19। यहाँ से देखोगे, देखो 9.1 का रूट लोगे तो अराउंड 3 कुछ आएगा हमारे पास में। ठीक है, तो इन दोनों में से कुछ ऑप्शन होना चाहिए। ठीक है, इनकी पावर्स को सॉल्व करोगे, पावर्स को जब सॉल्व करोगे तो यू विल गेट दिस एज द आंसर। तो थोड़ा-सा आपको मैनिपुलेट करना पड़ेगा यहाँ पर, ठीक है? थोड़ा-सा अप्रॉक्सिमेटली सॉल्व करना पड़ेगा, जब भी ऐसी टफ कैलकुलेशन आती है, तो अप्रॉक्सिमेटली आंसर निकालिए, ठीक है? ओके, नेक्स्ट क्वेश्चन, या looks from the diagram a very important question. A block of mass 3 kg and a charge 30 microcoulomb is connected to a spring of spring constant 300 Newton per meter. The block lies on a frictionless horizontal track in a uniform electric field. The block is released from rest. The amplitude of the oscillation is. So, in such question, when we have to find the amplitude, हमें energy conservation लगाना होता है. तो work done by all forces is equal to change in kinetic energy. All right. तो यहाँ से रेस्ट से रिलीज किया हमने, एंड जब मैक्सिमम डिस्प्लेसमेंट तक जाएगा या एम्पलीट्यूड पोजीशन तक जाएगा तो यहाँ वहां पर भी रेस्ट पर ही होता है। तो चेंज इन काइनेटिक एनर्जी तो जीरो हो गया। वर्क डन कौन कौन फोर्स करेंगे, वर्क डन बाय इलेक्ट्रिक फोर्स प्लस वर्क डन बाय स्प्रिंग फोर्स। ऑलराइट, सो दिस थिंग विल बिकम वर्क डन बाय इलेक्ट्रिक फोर्स, लेट्स से एक्स, ए इज द एम्पलीट्यूड, टेक इट एज ए। तो ई क्यू वर्क डन कितना हो जाएगा, फोर्स इनटू डिस्प्लेसमेंट, ये तो कांस्टेंट फोर्स होगा, इनटू ए माइनस ऑफ हाफ ऑफ के ए स्क्वायर वर्क डन बाय स्प्रिंग। सो हाफ के ए स्क्वायर is equal to EQ into A. So A and A gets cancelled. So from over here, A will get the value 2EQ upon K. So let's now put the values. So 2 into electric field has value 4 into 10 to the power 6 upon into the charge has value 3 into 10 to the power minus 6 upon K, and K has value 600. Right. So these things get cancelled. Uh, so the answer will be 0.4 meter. All right. Now we have to find the amplitude. This is the maximum displacement from like the natural length. Okay. तो मीन पोजीशन यहाँ से कहीं आएगा, ये तो एक्सट्रीम पोजीशन, ये वाली दूरी हमने निकाली है। दिस इज नॉट बेसिकली द एम्पलीट्यूड, दिस इज डिस्टेंस फ्रॉम द नेचुरल लेंथ टिल द एक्सट्रीम पोजीशन. Now the equilibrium position will come somewhere in the middle, so the amplitude will be 0.2 meter only. Okay, this entire thing is 0.4, this is 0.2, तो एम्पलीट्यूड जो आएगा इसका वो 0.2 मीटर आएगा। तो यहाँ पर एक कैच है, आपको ध्यान रखना पड़ेगा, ये जो हमने वैल्यू इनिशियली निकाला, इट इज नॉट एम्पलीट्यूड, इट इज बेसिकली द टू वे फ्रॉम दिस एक्सट्रीम टिल दिस एक्सट्रीम। ओके, नेक्स्ट क्वेश्चन, the dielectric strength of air is, so what is dielectric strength? It is the maximum electric field, you have to remember it. So maximum electric field can be 5 into 10 ki power 6 volts. So electric field near a solid sphere is how much? Kq by r square. So we have given the value 5 into 10 to the power 6 is equal to 9 into 10 to the power 9 into q we have to find, and radius is 1 ka square. So this thing will become how much? 5 by 9 into 10 to the power minus 3. So this can be the value of q जब dielectric strength itni hai. This is the maximum electric field that can be that can exist there. All right. A point charge particle is revolving around a long straight wire under the influence of electrostatic force. If the radius of the circular path is r, then the time period. Yeah, again, same similar question, but it's very important. That's why I've taken it. So same concept है, एक line charge है, उसके अराउंड एक चार्ज सर्कल में घूम रहा है. सो अगेन द इलेक्ट्रोस्टैटिक फोर्स जो होगा वही सेंट्रीपिटल फोर्स प्रोवाइड करेगा. बट हाउ विल फाइंड द इलेक्ट्रोस्टैटिक फोर्स ओवर हियर? सो वी नो दैट यहाँ पर एट द लोकेशन जहां पर की आर दूरी पर जहां पर की सर्कुलर मोशन हो रहा है और द रेडियस है, तो द इलेक्ट्रिक फील्ड ओवर हियर is 2k lambda upon r due to the infinite line charge. Now the force is eq, electric force is eq. The charge is negative basically, then only it will get a force in this direction. So the force will be 2k lambda r into q, and this will be equal to mv square upon r. So r and r get cancelled, so v square from over here will become 2k lambda q upon m, or v will become 2k lambda q upon m, and time period is 2 pi r upon v. So from here what we'll get, that the time period is coming out to be, v is not depending on r at all, so the time period is directly proportional to this r. T is proportional to r to the power 1. Next question. A capacitor of capacitance C is charged up to 90 volt and then connected to an uncharged capacitor of capacitance 2C. The final potential difference. So you have to remember this formula for charge sharing, that V common comes out to be C1 V1 plus C2 V2 upon C1 plus C2. So V common will be how much? C into 90 plus the another one is 2C into 0. It is uncharged, and the total capacitance is 3C. So it will become 90C upon 3C. So it will be 30 volts. सिमिलर क्वेश्चन में एनर्जी भी पूछी जा सकती है, व्हाट विल बी द फाइनल एनर्जी या फाइनल एनर्जी का रेशियो. तो व्हेन यू हैव द कॉमन पोटेंशियल डिफरेंस यू कैन फाइंड द एनर्जी अक्रॉस बोथ द एनर्जी स्टोर्ड इन बोथ द कैपेसिटर्स, लाइक बाय हाफ CV स्क्वायर एंड हाफ CV स्क्वायर और व्हाटएवर बी द कैपेसिटेंस उसके अकॉर्डिंग. तो इसमें एनर्जी का भी आपसे पूछा जा सकता है, चार्जेस पूछे जा सकते हैं. तो बट द फॉर्मूला दैट यू हैव टू रिमेंबर इज दिस वन. ऑलराइट, नेक्स्ट क्वेश्चन. Two similar balls of mass m and charge q, each are suspended by silk strings having length according to the figure. If in figure theta is very small, then for equilibrium the distance between the center of the balls is. So let's say this is L and the distance between the center of the balls is x. Theta is very small, so we can write that sine theta will be equal to tan theta, and sine theta is how much? This distance is x by 2. So sine theta will become x upon 2L. So that will be tan theta and that will be theta. Now हमेशा आप याद रखो, whenever you are given a string जिससे कुछ चार्ज हैंग कर रहा है and there is electric field or maybe another charge जो कि हैंग कर रहा है या इलेक्ट्रोस्टैटिक फोर्स लग रहा है, you have always have to remember that tan theta will be equal to F electric upon mg. This can be used everywhere wherever there is a string with a mass and a charge, and it is making some angle theta with the vertical in some electric field or in the influence of force of another charge. So you can always write that directly. Tan theta is equal to F electric upon mg. So let's put up the values. So tan theta is x upon 12. F electric will be how much? Kq square upon x square into mg. So x cube will become kq square L or 2kq square L upon mg. And from here we can write k को 1 by 4 pi epsilon naught लिख देंगे. So it will become q square L upon 2 pi epsilon naught mg. All right. So this will be my answer. So this looks like it. This one. So it's an easy problem. Equilibrium पर problem है. सरल है question. But still you have to be careful in the calculation. And इसमें दिया है theta very small है. तो tan theta का value हम इस तरह से लिख सकते हैं. And this formula you have to remember a direct result. Okay. Next question. Yeah. Maximum electric field on the axis of a uniformly charged ring. So how much is the electric field on the axis? Let's first write the formula. So electric field is kq into x upon r square plus x square to the power 3 by 2. This is the formula and it's a very important formula at a distance x. Now we know that electric field is maximum. E will be maximum when x will be equal to r upon root 2. How will we find it out? तो याद रखिए वो बेटर है. You'll have to differentiate it and put it equal to 0 and then you'll get कि x is equal to r by root 2 पे the electric field is maximum. So let's put the value of uh, x as r by 2 over here, both the places. So eq into r by root 2 upon r square plus r square by 2 to power 3 by 2. And when you solve it, you will become you'll get 2kq upon 3 root 3 r square. ये भी आप डायरेक्टली याद रख सकते हैं एज डायरेक्ट रिजल्ट. इसका लिए ग्राफ भी बनता है. इफ यू वांट टू ड्रॉ अ ग्राफ फॉर इलेक्ट्रिक फील्ड फॉर अ रिंग, तो वी नो दैट सेंटर पे तो जीरो होती है. तो ग्राफ गोज लाइक दिस maximum value is at x is equal to r upon root 2. This is also r upon root 2 minus r upon root 2 and E max has this value. तो ये इतनी सारी चीजें आपको इस पर याद रखनी है. आई होप याद रहेगा आपको. नेक्स्ट क्वेश्चन. The length of each side of a cubical vessel is L. If charge Q is located at one of the vertices of the cube, as shown in the figure, then the flux passing through a shaded portion. यहाँ पे flux through surface पूछा है आपने. Now we know that जब corner पे रखते हैं तो charge gets shared among 8 cubes. So charge through the entire flux through the entire cube will be equal to how much? Q upon 8 epsilon. Because in every cube 1 by 8 of the charge will be there. Now flux through the face in this case will be q upon 24 epsilon naught, because there are total 6 faces. 3 faces से जो इलेक्ट्रिक फील्ड लाइंस होंगी वो टेंजेंशियल होंगी, तो उनसे कोई फ्लक्स नहीं होगा. जो सामने वाले फेसेस होंगे उनसे फ्लक्स निकलेगा एंड दे विल बी सिमेट्रिकल. तो बराबर बराबर फ्लक्स सबसे निकलेगा. तो 3 फेसेस होते हैं सामने क्यूब में, आप देखेंगे तो एक फेस से क्यू बाय 24 एप्सिलॉन नॉट जो है फ्लक्स बाहर आता है. ऑलराइट. नेक्स्ट क्वेश्चन. A small dipole of dipole moment P is kept at the center of a ring of radius A and uniformly distributed charge Q. The dipole moment has direction along the axis. The resultant force on the ring due to the dipole is. So, see, basically every action has equal and opposite reaction. So, if we keep it on the axis, okay, then the force on the dipole or electric field at the location of dipole will be zero. Okay, so force will be zero. So force due to dipole will also be zero. So our answer will be zero only. Okay. ऐसे भी देखेंगे हम. Two negative ions each carrying a charge q are separated by a distance d. If the force of repulsion between the ions, then the number of excess electrons on each ions. नंबर ऑफ एक्सेस इलेक्ट्रॉन्स हमें निकालने हैं, तो बेसिकली चार्ज हमें निकालना है, एंड Q इज इक्वल टू एन ई से हम नंबर ऑफ एक्सेस इलेक्ट्रॉन्स निकाल सकते हैं. अगेन एप्लीकेशन ऑफ कूलम्स लॉ ओनली. तो टू नेगेटिव आयंस ईच कैरिंग चार्ज Q आर डिस्टेंस d. तो F इज इक्वल टू 1/4 पाई एप्सिलॉन नॉट इंटू क्यू स्क्वायर अपॉन डी स्क्वायर है. ऑलराइट. सो यहाँ से जो मेरा Q का वैल्यू है, इसको मैं K ही लिख देता हूँ तो बेटर है. इट विल मैच द ऑप्शंस. So this is K. So F d square upon K will be equal to Q square. So the Q will become under root of F d square upon K. And this Q is N into E. So we have to find the value of this N. Alright. So N over here will become F d square upon E square into K. Alright. So ऐसा कुछ ऑप्शन ये दिख रहा है हमें. This will be our answer. Alright. Next question. यूनिट ऑफ कांस्टेंट के. इट्स वेरी इंपॉर्टेंट. लुक्स वेरी इजी बट बहुत बार बच्चे इसको इग्नोर कर देते हैं. तो कैसे निकालना है? फॉर्मूले से निकालो. जो भी बेसिक फॉर्मूला याद है, के क्यू स्क्वायर अपॉन टी स्क्वायर. सो के का जो यूनिट हो जाएगा वो न्यूटन मीटर स्क्वायर अपॉन कूलम स्क्वायर हो जाएगा. ठीक है. तो न्यूटन मीटर स्क्वायर अपॉन कूलम स्क्वायर. दिस विल बी द आंसर. ये होल स्क्वायर नहीं होगा, ये नहीं है. दिस विल बी द आंसर. ऑलराइट. Four identical point charges, each of charge Q, are placed on the vertices of a regular hexagon of side A such that net electric field at the center of the hexagon is zero. If now one charge is removed, then the electric field at the center will be. So again, a very important question. Very important. So we have an hexagon, and charges are kept on the vertices. So obviously the net electric field at the center will be zero only. Now let's say this charge is removed, this one. If this charge is removed, then the electric field at the center will be in this direction only, and will be equal to the electric field that was being produced by this charge. We can see it this way कि ये वाले चार्ज ने बाकी के 5 चार्जेस की इलेक्ट्रिक फील्ड को बैलेंस करके रखा होगा. ठीक है. तो ये हटा देंगे तो इन दोनों का रिजल्टेंट भी इसी के बराबर आएगा. तो वो कितना हो जाएगा? के क्यू अपॉन ए स्क्वायर. सो दिस विल बी दी आंसर. तो इसमें याद रखिए, जब भी ऐसे हेक्सागन में से हम या कोई पॉलीगन में से हम हटा देंगे एक चार्ज को, एंड नेट जो था वो पहले जीरो था सेंटर पे, तो जिस जिस लोकेशन का चार्ज हटाया है उस ही डायरेक्शन में हमारी इलेक्ट्रिक फील्ड आएगी, एंड उस चार्ज की वजह से जितनी इलेक्ट्रिक फील्ड थी वही मैग्नीट्यूड होगा. ऑलराइट. नेक्स्ट क्वेश्चन. 3 point charges plus q minus 3q and 2q are placed in xy plane at points x, comma 0, 0, comma a, 0, comma 0 and a, comma 0. The magnitude and direction of dipole moment. Again, a very important question. Very important. Dipole moment निकालने पर सवाल definitely पूछा जा सकता है. So let's draw the axis. So this is my y and this is my x. So our charges are kept कैसे? एक charge, the plus q charge is at 0 comma y. So 0 comma a basically, 0 comma a. So q charge, uh, minus 3q charge is kept at the origin. So here it is minus 3q, 0 comma 0, and one charge is kept on the x axis a comma 0, and उसका मैग्नीट्यूड है 2q. अब यहाँ से डाइपोल विजिबल तो है नहीं हमें, लेकिन एक डाइपोल यहाँ पर मिल तो रहा होगा हमें. डेफिनेटली हमें ढूंढना पड़ेगा उस डाइपोल को. कैसे ढूंढेंगे? तो लेट्स ये जो नेगेटिव चार्ज दिया है इसको हम डिस्ट्रीब्यूट कर देते हैं माइनस टू क्यू और माइनस क्यू में. तो अब देखिए इक्वल एंड ऑपोजिट चार्जेस दिख रहे हैं हमको, एक ये और एक ये. ऑलराइट. तो एक डाइपोल है मेरा जिसका डाइपोल मोमेंट इस डायरेक्शन में होगा क्यू इंटू ए, और एक डाइपोल है मेरा जिसका डाइपोल मोमेंट इस डायरेक्शन में होगा टू क्यू इंटू ए. ठीक है. ए जो इनके बीच की दूरी है. तो अब ये डाइपोल मोमेंट इज अ वेक्टर क्वांटिटी. इनका हम रिजल्टेंट निकालेंगे. तो इट विल कम समवेयर ओवर हियर, एंड उसका वैल्यू जो होगा मेरा वो हो जाएगा क्यू ए होल स्क्वायर प्लस 2QA होल स्क्वायर. So it will become under root of 5 into Q into A. And अगर हम एंगल निकालने जाएंगे तो tan थीटा will be equal to QA upon 2QA. So it will be 1/2. ठीक है. तो मैग्नीट्यूड जो होगा वो √5QA होगा एंड द एंगल विल बी tan इनवर्स ऑफ 1/2 फ्रॉम x एक्सिस. ठीक है, x एक्सिस से एंगल लिया है अपन ने. तो दिस विल बी माय आंसर. सो these are some questions which are in high probability to be asked in the NEET exam this year, the re-NEET exam. Similar questions आपको देखने को मिलेंगे जो भी हमने आज किया था. I have tried to cover all the uh, questions that were in line with the PYQs. Formulas और भी हैं इस चैप्टर में. You have to learn those formulas, practice basic and standard questions of NCERT, and you are gonna do great. So we'll meet again in the next lecture with some new chapters, and I hope you are working hard, revising all the formulas, doing all this basic and standard stuff that has been told to you many times. So let's meet in the next class. Thank you very much. All the best.